Good morning, all. Today we are going to see the alternate approach to design a rigid pavement that is known as PCA method. This method addresses the plain cement concrete slab thickness determination regardless of the slab type. You can use any slab type, whether it's a jointed plain cement concrete, jointed reinforced cement concrete, or continuously reinforced cement concrete pavement. It also gives recommendation about the design of joint. This PCA methods comes from the Portland Cement Association in 1984. In this method, finite element methodology is used to determine the critical stress and deflections. A program JS Lab has been developed to determine critical stresses and deflections in this method. This method is based upon mechanistic empirical approach that addresses two basic form of the failure. Like we have seen in case of flexible pavement, we have two modes of failure, one due to fatigue and second due to rutting. Now, fatigue is also a problem in rigid pavement, although rutting doesn't happen in rigid pavement. But what can happen? Your subgrade or supporting layer can erode due to erosion. That erosion may happen due to increase of moisture or any other phenomena due to weathering, etc. So this methodology addresses two mode of failure mechanism. One is fatigue cracking and second is the erosion failure of supporting material. PCA method is developed by identifying the forces and material properties which are responsible for these failures. That means for fatigue as well as the erosion. It relates the theoretically computed stresses, deflection, and forces to appropriate pavement performance criteria. Here, performance criteria is again a failure that is in two mode, in fatigue and in erosion. The method is developed by major road test programs. Models and full-scale pavements are being tested. Performance of normally constructed pavements subjected to normal and missed traffic is assessed in order to assess the performance of the pavement. In previous methods, in order to determine the traffic load, we converts all the axle loads of all the axle configuration into a equivalent standard axle configuration. But here in this method, we'll use a load safety factor to convert the different factors, different axle loads to the design loads. These load safety factors will depend upon the type of roads and the amount of volumes and the category of volume that road is having. Like in the case of interstate highway or multi-lane projects which is having uninterrupted traffic and high volumes of truck, the load safety factor for this kind of roads will be 1.2. Roads of lesser priority, let's suppose arterial streets with moderate volume of truck traffic, the load safety factor will be lesser, that is 1.1. And for all the other roads which are lesser priority, the load safety factors will be 1. In terms of material properties, the input requires will be flexural strength of the concrete, modulus of rupture MOR, and subgrade and subbase support in terms of modulus of subgrade reaction K will be required. So as we have already seen, there will be two failure mechanism in this design process. One is the fatigue and second is erosion. So let's first address the fatigue mechanism of failure. Fatigue design for the slab thickness is performed with an aim to control the fatigue cracking in the slab. The design is based on the most critical edge stresses. So design is being done when your vehicle's two wheel is on the edge of the pavement or your vehicle is crossing to the edge portion of your slab. For fatigue design, the computed slab thickness is same for all categories of rigid pavements. Either they are dowelled or undowelled or they are continuously reinforced. However, if the concrete sources are tied with the existing slab, that case must be considered during design process. Because if the pavement slab is tied with the soldiers, then the critical stresses on the edge will reduce significantly, and you need to take care of this reduction during the fatigue design. PCA fatigue design analysis is done based on the cumulative damage approach. Suppose you have m different class of vehicles, and for each class of vehicle, let's suppose I is a class of vehicle, then for ith class of vehicle, n is the number of passes actually happening on the pavement slab, and ni, capital Ni, is the number of passes which can be sustained by the pavement slab. In this case, the small ni divided by the capital Ni, that means actual passes upon the allowable number of passes, will give you the damage factor for the ith class of vehicle. So if you have m number of class of vehicles, then summation of all class of the vehicle will give you the damage factor due to fatigue. For pavement which is safe in taking the load, this damage factor D should be greater than or equal to 1. What it means? It means the number of passes actually happen should never exceed the allowable number of passes on the slab. Let's see how to design the slab thickness based on the fatigue design procedure. So step 1 will be to multiply the load of each design axle load group by an appropriate load safety factor. Assume a trial slab thickness. So this will be a trial and error process. You need to assume one trial thickness and then you need to determine the value D. Knowing the modulus of subgrade reaction K, go to a table. The table is in next slide. Equivalent stress for the projected slab thickness and calculate the stress ratio factor. So equivalent stress you need to read from the table, and the modulus of rupture will be given to you. The ratio of equivalent stress upon the modulus of rupture will give you the stress ratio factor. So this is the table. So in this table there will be two classes. One for a pavement which is having a concrete soldier and one pavement which doesn't have a concrete soldier. So this is a class when you don't have a concrete soldier. So let's see how to read the table. Let's suppose you have a K as 150 and you have assumed the thickness as 10. So this is going to be your equivalent stresses. Now what it means, 186 upon 137. So this table is valid for single axle and tandem axle both. So 186 is for single axle and 173 is for tandem axle. So for a case when you have K equals to 150 PCI and slab thickness assumed as 10 inches, you will have a equivalent stress 186 in case of single axle and 173 in case of tandem axle. Once you have read this equivalent stresses, you can calculate the stress ratio factor by dividing this equivalent stress by modulus of rupture. This will be used further. Fourth step will be to use the stress ratio factor and different axle loads to determine allowable load repetition. So how to read this nomogram? Let's suppose you have a single axle load of 36 and you have a stress ratio factor 3.17. This will be the value. So if you have a load of 36 skips in single axle and you having a stress ratio factor 0.317, you will have the number of repetition as 25,000, or sorry, allowable number of repetition as 25,000. Once you know the allowable number of repetition, you already know how many repetition of that load So the repetition of that load actually divided by the allowable number of repetitions will give you the cumulative damage D. Summation of this D for all classes will give you total D. This total D should not exceed 1. Either it should be equal to 1 or less than 1. In case you are getting a D value lesser than 1 that or equals to 1, that means your design is safe. In case you are getting D value greater than 1, you need to revise the assumed thickness of the slab. Whatever you have assumed, just increase that thickness and repeat this procedure. So this is the procedure when you want to design your rigid pavement using PCA method for fatigue. Next failure criteria for design using PCA method is erosion design. The PCA erosion design for the pavement thickness design is to guard against foundation and soldier erosion, pumping and any faulting failure in the rigid pavement. What are these different types of failure or distresses in rigid pavement? That we will see in the different part of lecture, or we'll see this in detail in your pavement maintenance course. The critical point is when your vehicle is at the corner of slab. The erosion design will be affected by the type of joint construction and the presence of shoulder with the slab. So in case your shoulder is tied with the slab, you are using a dowel bar, there will be less erosion, and that's how this will affect your erosion design. Again, a cumulative damage approach will be applied to design the slab in erosion failure. These are the different steps to design the rigid pavement using PCA method in erosion. So multiply the load of each design axle load group with LFS. This remains same as we have seen in case of fatigue design. Assume a trial thickness. This is again the same. Obtain from the table the erosion factor for the projected slab thickness and the modulus of subgrade reaction. Again, one table will be given which will include erosion factors for different modulus of subgrade and for different assumed thicknesses. This is a typical example of erosion factor table. So here, corresponding to a thickness, a slab thickness for a value of K, you can read a corresponding erosion factor. So this is the case when your slabs are dowel jointed and no concrete shoulder is present. So in this case, if I have a K value of 100 and I have assumed a slab thickness of 10, you can read the erosion factor as 2.54 in case of single axle and 2.76 in case of tandem axle. Once you have read this erosion factor for different class of road, you can move to next step. Next step will be using this erosion factor, you have to estimate the allowable number of load repetition for that class of load. That will be done by using a different nomogram, which is in next slide. So this is the nomogram which you can use to read the allowable number of passes in erosion. Let's see how to read this graph. Let's suppose you have this much of load. You know that this is my erosion factor. You can extend the line to intersect that to a allowable number of repetitions scale, and from here you can read the allowable number of repetition or Ni in erosion. Now small n will be given to you how many repetitions your vehicle will move on the pavement in design period. An allowable number of repetition you have calculated. Using this small n I and n capital Ni, you can estimate the damage factor for that class of vehicle. So here in this case, if you have a single axle, you need to use this upper scale, and if you are having a tandem axle load, then you have to use this lower scale. and these are the allowable number of passes when your pavement slab doesn't have any concrete soldiers. Similar homogram we have in the case when we have a concrete soldier. Once you have read it, the allowable number of passes, that means capital Ni, you can take the ratio of the number of passes small ni upon the capital Ni. That will give you the damage factor D. This D again should be less than or equal to 1. In case this D is greater than 1, you need to revise the assumed thickness of slab. If D is less than or equal to 1, that means your pavement slab thickness is safe for erosion. So the overall steps for design or slab thickness using this PCA method will be to assume a thickness. First do a fatigue design and see whether that thickness is safe in fatigue or not. Again carry forward that slab thickness and check it for a erosion. If it is safe for both fatigue and erosion, then you can say that your this thickness is a design thickness or adequate thickness which you can provide in the field. Otherwise, if your pavement slab thickness fails in any criteria, whether fatigue or this erosion, you need to revise that slab thickness and again repeat the design. So the final design thickness of the pavement slab is equal to or larger of the thickness obtained from the fatigue and erosion analysis. Let's try to solve an example. Let's design a slab thickness for an expressway with a design traffic shown in table. The table I put it in the next slide. The pavement is to be constructed with a dowel joint but without concrete shoulder. Concrete modulus of rupture is given as 650 pound per inch square. The modulus of subgrade reaction is given as K equals to 130 PCI. So we know the value of K, that is 130 PCI, and we know the value of modulus of rupture MOR, that's as 650 per inch square. So this is the table which gives a different class of vehicles or different class of loads and their repetitions. So like this first entry 52T, that is 52 kips tandem axle load, and its repetition is 3100 on the pavement in the design life. So if this is the table here, in order to calculate the design load, we first need to multiply a load safety factor. So in case of expressway, this is the road category of expressway, we need to take a load safety factor of 1.2. So in order to calculate this design load, what we have to do, we have to multiply all these axle loads with a factor 1.2 in order to estimate design load. So let's calculate it for first load. So for first load, the load is 52 kips, multiply it 1.2, you will get a value of 62.4 kip. So calculate for all, you will get different design loads for different class of vehicle calculated in this table. So for first, you will get a value of 62.4. This is a tandem axle load, and let's suppose for last 22 kip of single axle, if you multiply it by 1.2, you will get a value of 26.4, and that will be a single axle. So here up to this point, this will be tandem, and from here onwards this will be single. Do this for all the load, you will get the design load corresponding to each axle load. Next step will be to assume some slab thickness. Let's assume a thickness of 9.4 inches. Third step will be to calculate the stress ratio factors. So in order to calculate the stress ratio factor, you need to determine the equivalent stress. For this, you will require equivalent stress table. So you already know that the slab thickness you have assumed is 9.5 and K is given to you as 130. So now 130 comes in between 100 and 150. So you need to do some interpolation. So for single axle, the equivalent stress should be in between 215 and 200, and for tandem axle your stress should be in between 205 and 183. You can do the interpolation part. You will get a equivalent stress of 206 in case of single axle load and a equivalent stress of 192 in case of tandem axle load. So in order to calculate the stress ratio factor, you need to divide these equivalent stresses with modulus of rupture MOR, that is given as 650. This will give you stress ratio factor. So stress ratio factor for single axle after dividing 206 by 650, you will get a value of 317, and stress ratio factor for tandem axle you will get a value of 0.295. After calculating this stress ratio factor, we move to next step, that is step 4, that is calculation of allowable number of repetition. So that you will do by using nomogram. So you need to use this nomogram in order to calculate the allowable number of repetition. So if you have a load, go to the stress corresponding stress ratio factor, extend the line to the allowable load scale, and from this scale read the allowable number of repetition. Do it for all loads. Do it for all the loads. If you do for all the loads, you will get N1 as calculated in this table. Take the now next step will be to estimate the value of N upon Ni. So small n is already given to you, capital N, or that means the allowable number of repetition you have estimated. Just take the ratio, you will able to calculate the N upon N1, that means the damage due to that class of load, and take the summation of this damage. Here the summation of this damage comes out to be 0.982. This 0.982 is less than 1. That means the slab thickness 9.5 which you have assumed is safe in fatigue design. Similarly, you have to design for erosion and check whether this slab is safe for erosion or not. The solution for this problem is already given in the slide, or you may refer this table for the solution. So for both fatigue as well as for erosion, this D or damage factor are less than 1. That means 9.5 inch thickness of the slab is satisfactory for this pavement requirement. That's it for PCA pavement design. In next class, we'll see IRC 58 method to design a rigid pavement slab. Uh, Comment on this video if you have any doubt. I will try to address all the doubts in the next lecture. Thank you.